So 1.7, solving linear systems using matrices. So first you need to know what a matrix is. A matrix is a rectangular array of values. So you have square brackets. Normally the brackets go like this, not short. Okay? They're rectangular. Squares are also rectangles, yes? Yes? Okay.
Yeah.
So there are many different shapes. They can be 2 by 2, they can be 4 by 4, they can be 20 by 20, they can be 2 by 10, they can be 10 by 2. They have all sorts of dimensions. Okay, when I just said dimensions are rows by columns. So this has 2 rows by how many columns? 2 columns. So that is a 2 by 2 matrix. The next one has how many rows? 3.
By 2.
By 2. Always rows, then columns. Columns are like columns in a building. They go up and down. Rows go sideways, just like a row in an Excel spreadsheet. Okay? If you get confused which comes first, think about it this way. Could you have a column without a row?
No.
No, because you have to start and go up. We say this is row 1, row 2, row 3, column 1, column 2. Can you say that again, please? I cannot hear you at all.
God.
Hello? Yeah, but you are not over my intercom. That was weird. Yes, she is. Okay. Bye. That's weird. Go to the office. I'm recording, so. Okay. Okay, coefficients are the numbers in front of variables. Something you learned a long time ago. Okay, coefficient matrices are full of a bunch of coefficients. So if I have ax plus by equals c and dx plus ey equals f, the coefficient matrix would be a, b, d, e. So 2x plus 3y equals 1, 4x minus 2y equals 10. My coefficient matrix would be 2, 3, 4, negative 2. Make sense? You don't put the positives, you put the negatives. Because if it's not negative, the assumption is that it is what? Positive.
Where do you get 1 and 10?
That's just the problem.
Okay.
Like right here. Why did it do that?
Where is right here?
That's not going
Right here.
in the middle.
Right here is what you're talking about? That's just the problem I gave you. We're not talking about them yet. Okay? Now we have an augmented matrix. An augmented matrix means that it's modified. Augmented matrix, or it combines 2 things, sorry. You take the coefficients and the constants or the solutions. So you have the coefficients and then a dotted line. It is not solid, it is dotted. And then the coefficients, the solutions. If you notice, this column is the x column, correct?
Yep.
This column is the y. And this is the solution or the equals. Well, actually, the dotted line is the equal. And then you have the solution. This is the first equation, and this is the second equation. So, in order to make an augmented matrix, do you have to have them in the same order?
Yes.
Yes. We always put them in alphabetical order. So, when we get to 3, it will be X, Y, Z. Okay, so now we all know what a matrix is. You all could tell me what an augmented matrix is, hopefully. We will be making, from a system of equations, we will be making an augmented matrix to use this method. We are going to take out the x's and the y's. We're going to get them out of there. But we always know that this is the X column. We always know this is the Y column, and we always know these are the solutions. Okay? So, write an augmented matrix for 3y equals 1 minus 2x and 4x equals 10 plus 2y. So it was the first thing I had to do.
Make an array. I don't know.
Does that look like it should look?
Mm-mm.
No.
You get the X.
I need to get the x's and y's on the one side. It needs to be ax plus by equals a constant, yes? So I need to do that.
So you just
I would add the 2x over there, right? So I have 2x plus 3y equals 1. And on this one, I would subtract the 2y.
Yep.
So 4x minus 2y equals 10. So now in order to make an augmented matrix, I have 2,
2,
3,
1.
1, and then 4, negative 2, 10. Now, is it going to be beneficial to me to write things neatly?
Yeah.
Yes,
Sure.
definitely. If you are not neat, if you can't tell there's a negative, it's not going to work. You are going to mess it up. I can guarantee it. Okay, so the next one I have 3 variables, so that means I should have 3 equations in order to get a unique solution. Those would be 3 different lines, so actually planes, but they would all intersect at one spot to have a unique solution. Okay? Just like the last were one spot for 2. So are they in the right order this time?
Yeah.
Yes. The first one doesn't have a z, so what's there? Isn't it a 0 z? Okay. So, what's my first number?
1,
1,
2,
2,
0.
0.
Big
And then
1.
1,
Negative 1, 3, 5.
and
2,
2.
1, negative 4.
Okay, so makes sense. Everyone makes sense to you? So this is an X column, Y column, Z. So the next one says write a system of equations. So I have to go backwards. Well, 0 means it's not there, right?
Yeah.
But this, again, what column is this first column?
X.
X, then Y,
Y, Z.
Z, and this is your equals, right?
Yep.
Okay, so you do it. Why are you playing with the glue stick? Just asking. No, what's the first equation? I know, that's why I asked you. So let's do it. Let's do it. What do you put for, do you need to put an X?
I haven't even wrote the first part.
Okay, so Noah, just do it with me up here. Do I need to write an X? It says 0. Do I need to write it?
No.
No. How many y's do I have, Noah?
3.
Okay, do you see the y? How many y's do I have in the first row?
First row. 2.
So it's 2y. Plus or minus?
Plus.
How many is these?
3.
Equals what?
4.
Jenna, next one.
AX minus 1y minus 2z equals 5.
Carson,
Hmm.
next one.
2x plus 1z equals 9.
Pretty easy?
Very.
Why would you not line it up?
Is that it? Is that like the whole how you do everything?
The very first step.
That's the first.
You just gotta you gotta be comfortable with the matrices before I throw you in the deep end yet.
Are we gonna have to graph these?
No.
How would you graph? There's no C
I don't know.
axis.
Something about graphing.
Well, there is, but there is not. Okay, so right here are some rules that we can do. Okay, these are important to know that we can do them. So they're important to write down. Okay, of the matrix, you can switch the rows. I said rows, yes? I didn't say like terms. You can switch the rows around if you'd like. You can multiply rows by non-zero constants. Okay, why can't I multiply it by 0?
Because then I'll be 0.
Then it'd be 0. You can't multiply by 0. Now, you notice I did not say divide, did I?
Uh-huh.
So how would I divide by 2?
What do you mean?
How would I divide something by 2? If I wanted to divide it by 2, how would I do that?
Half
I'd multiply by half.
or
Yes.
fraction, pretty much.
I multiply by the reciprocal of what I want to divide by.
Hold on a second. I'm writing all this down.
Okay.
Do you have to write everything down?
I would write the first 2 columns, at least. The other one's an example.
The first two.
Columns.
So the first 2 columns, this tells you what you can do. The second column is just that in words. I probably would do these 2 columns if I was writing.
Each one.
Okay, so you can switch 2 rows. You can multiply a row by a non-zero constant. I can add 2 rows together.
Or you subtract.
Well, basically you can combine, because if you were going to subtract, you would have multiplied by a negative. So I like to just think of it as combining, but yes, you can. The problem with the subtraction part of it is you forget to distribute the negative. Does that make sense? So yes, you can add or subtract. Okay, and the last thing is we are going to have this in reduced row echelon form.
Oh
So it's RREF, reduced row echelon form. If you notice, actually, what do you notice about it? There's ones on the diagonal. Okay. The reason why that's beneficial to us is because then if this is x, it equals -4. If this is y, it equals 2. If this is 1, it equals 7. Because this is x, this is y, and this is z. Every single problem, you will need to get it into reduced row echelon form. Every single problem.
Where'd you get 7, 5, and 16 on adding and subtracting?
Okay, so
Never mind, I see it.
okay, so what would happen is this technically, when we had it, we would have 2, 3, 7, 5, 2, 9. And our next step would be R1 plus R2. So R1 didn't change. And I wrote it next to row 2. That's what's changing. So R1 plus R2 would be
7, 5.
7, 5, 16. So this is how we will write this, not like this.